Okay, so this will be a video on vectors. It will be 3 parts based on our agenda or our objectives. So, ang objectives natin, differentiate vector and scalar quantities, associate corresponding direction to the axis and quadrants of the coordinate plane, and determine ways that a vector can be presented either by illustration, magnitude and direction, or use of coordinates. So let's begin with differentiating vector and scalar quantities. So when we say scalar quantity, it comes from the word scala, which means steps or ladder. These are quantities that can be completely described by their magnitudes and appropriate units. Pag sinabi nating magnitude, is just a numerical value. So, gaano kalaki, gaano ka konti, gaano karami. So, an example of this is mass, or for example, 1 kilogram, temperature, 30 degrees Celsius, for speed 4 meters per second, time 3 p.m., work is 5 joules, energy is also 5 joules, distance is 2 meters. So you can see, binigay lang sa yung magnitude and then yung appropriate unit mo. How about a vector quantity? A vector quantity comes from the word vehere, means to carry. So this is just a scalar quantity, but the main difference is that it has its direction. So may magnitude ka, may unit, at may direction ka. It's very important for direction to have direction kasi you want to know, for example, saan ka papunta. For example, you apply the force, is it a push or a pull? It's very important in terms of also solving problems kasi either yung backward means a negative sign, a left means a negative sign, a forward or going to the right is a positive sign. So an example of this is force, push or pull, displacement, velocity, and acceleration. Now, again, going back to a scalar quantity, bakit wala siyang direction? Imagine mo na lang kung makilo ka, I am 58 kilograms to the right, 59 kilograms to the left. So, walang ganon. Or time na 5 p.m. upward. So, walang ganon. Okay? So, ang meron lang yung mga vector quantities. Now, let's proceed with distance versus displacement. So, this is very important because displacement is discussed as a resultant vector in vector addition. So, what we need to understand is what's the difference between them and why is displacement very important. Now, here, suppose that the distance from your classroom up to the cafeteria is 25 meters, and if you go back and forth, how much is the distance covered, and how about your displacement? So sabi dito, from the classroom, you went to the cafeteria and then went back to the classroom. So what will be your distance? Of course, your distance will be 50 meters. 25 plus 25 kasi bumalik ka. So this is the total ground covered. How about your displacement? Now, displacement is basically defined as how far you are from the initial point to your final point. So, gaano ka kalayo sa initial to your final point. So, dito, from the classroom, you went to the cafeteria, and then bumalik ka sa classroom. How far are you from your initial point? Wala. So, ibig sabihin, this is 0 meters. Okay, 0 meter in the general. So, if we try to put it in graph, pwedeng ang distance mo, ganyan. Kung saan-saan ka pumunta, di ba? But your displacement will always be a straight line from your initial point to your final point. So, this is your displacement. So, yan, yung mga distances mo pwedeng divided into segments, depende rin sa pinuntahan mo. So, case on problem solving, napakadali lang siya. But for displacement, it's always your distance from your initial point to your final point. Okay? So, I hope that's clear. Okay, so how are vectors represented? So generally, vectors are represented by bold letters. Pero pag nagsusulat tayo, hindi naman tayo pwedeng mag-bold ng letter A na igaganyan talaga natin. So what we do is just put an arrowhead to signify that this is a vector. Okay, capital letter with an arrow on top denotes a vector. So in some books, naka-italicize siya, tas ganyan, basta may arrow siya sa taas. Now, how we write vectors on paper may have something to do with how they are drawn array. So, meron ditong, kasi ang pag-draw ng vectors is an arrowhead. So, ibig sabihin, parang ginawa na lang siya para mas madali sa part natin. Okay? Sige. Vectors can also be seen as a magnitude with direction. So, sabi natin 5 meters Newton. 5 meters north. This is a displacement in general. So, meron kang direction. Hindi pala Newton. Okay? So, We can also represent vectors as a magnitude with direction. Pwede rin natin siya i-represent with a pair of coordinates. So, in-introduce lang namin siya that vectors can be represented in many ways. And additional note lang, since a vector includes a magnitude and direction in general, ang ganitong sign po, this one with an absolute value sa vector means this is the magnitude. Okay? Ang kinukuha natin yung numerical value ng vector na yon. So, it's in an absolute sign because it's always positive. Kasi nga, magnitude siya. Imposibleng magka-negative ka sa magnitude. Okay, just an additional note. Now, if vectors have the same direction, they are parallel. If vectors are in the opposite directions, they are anti-parallel. If vectors are anti-parallel at the same time has the same magnitude, we can refer to them as the negative of each other. Okay. So since we know how vectors are now represented, how do we now draw vectors? So vectors are drawn usually by an arrowhead at its tip, tapos it's just a line. So the length of the line shows how shows the magnitude and the direction, and how big or how small is it. For example, sinabi natin 5 meters east. Okay? 5 meters east lang siya. So, kung east to, ganito yung 5 meters mo. Compared it with 100 meters east, ganyan yan. Okay, kasi mas mahaba siya. But this is basically with scaling. So, sabihin natin 1 inch is equal to 1 meter. Something like that. But we'll not be discussing this yet kasi iba pa yung additional vectors. Pinakita lang sa inyo dahil this is how we draw vectors. So, pwedeng ganyan. Basta meron kang tip, arrowhead na tip siya.